This is going to start in about 5.4 billion years. The Earth's temperature is going to rise rapidly. Water will vaporize. The atmosphere will blow away. The ocean will blow away. And life will be destroyed. Life as we know it, anyway. Some red giants expand and contract with periods ranging from less than a day to more than 100 days. So imagine something this size expanding and contracting over a period of a month or so. The collapse of the core raises its temperature to 10 to the 8th Kelvin, which is high enough for two helium-4 nuclei, to come together to form a beryllium-8. This beryllium-8 has a very short half-life, but in the dense core, a third helium-4 has a chance to collide with this beryllium-8 and produce a carbon-12, a stable isotope of carbon. In our sun, this phase lasts about 1 billion years. Now, these are not abnormal stars, the red giants we observe. They're basically old stars that are suffering a fate that we expect for our own sun. Our sun is now middle-aged. It's never been and never will be as large as the supergiants, and so it will only achieve red giant status at about 100 times the diameter it is today. It's still pretty big. Even that will be bad news for Earth in a few billion years. We're going to be absorbed and pulled into the core of the sun. Some look forward to that. The biggest stars are known as KW Sagittarii, V354 Cephei, and KY Cygni. These are all in our Milky Way galaxy and within 10,000 light years of our sun. So these are recent, they are big, and they are nearby. And that gives us a chance to look at them, and we observe changes in them over our lifetime. In fact, even over annual cycles. A light year is the distance light travels in a year. It's equivalent to about 6 trillion miles or 10 trillion kilometers. Despite the enormous size of these stars, they're not the biggest in the universe. An MIT undergraduate named Emily Levesque found that at 25 solar masses, these red supergiants would look tiny, shrimp-like, krill-like, compared to stars that can be up to 150 times the mass of the sun. As an example, UY Scuti is 1,780 solar diameters. It's the size of 1,780 of our suns placed side by side. Now, when you get a chance, check out this video. I've posted it in your module. I'd recommend turning the volume down. Not that the music's bad, but it's a little bit too much. The best known red supergiant is Betelgeuse, which is about 650 times the diameter of our sun, and because of its proximity to us, it's the 10th brightest star in our night sky. This is easy to find when you look up at night with the naked eye. Look for the hourglass. This is Orion the Hunter. It forms his right shoulder. And you may notice that somewhere down here off the screen, there's a very bright star named Sirius. This is the dog star. It's his faithful dog. This is an image of Betelgeuse indicating the degree to which we can observe things happening on its surface. Many other reactions occur during this time of creation of elements that generate heavier elements and some free neutrons. We combine a carbon-13, which is another stable isotope of carbon, with helium-4, and we end up with an oxygen-16 plus a neutron. This is the most common form of oxygen. An oxygen-17, also a stable isotope, combines with helium-4 to generate a neon atom plus a neutron. Neon-21 plus helium-4 come together to form magnesium-24, the most common form of magnesium, plus a neutron. And this continues all the way up to bismuth-209, the heaviest stable isotope. There are, I think, 1,300 radiogenic isotopes. Obviously, we won't cover them, so there are a lot of isotopes out there. And most of those are fairly short-lived. Some, though, have half-lives of billions of years, many billions of years. Once the helium is used up in a sun, the core becomes fused carbon. If it stops producing energy and collapses again, now it gets really excited and releases a much greater amount of energy. So for some examples here, our sun is radiating at about 5,800 Kelvin. The smallest red giant is radiating at about 5,000 Kelvin. And the largest example is radiating at 4,500 Kelvin. So this very large star is a lower temperature than our sun, but it's a much larger size. The amount of energy being given off at any time is much greater for this larger object, even though it's at a lower temperature. At this stage, a star becomes a red supergiant and its luminosity increases 1,000 to 10,000 times. Our sun will expand beyond the orbit of Mars with hot solar plasma engulfing the Earth and slowing us down. This is going to happen to all the inner planets, and we will all become part of the sun. The frozen atmospheres of the outer planets will be vaporized, and their rocky cores will now be exposed. The star Betelgeuse is a great example that we can look up and see at any time. When these stars lose half their mass to space, they collapse into carbon-cored white dwarfs the size of Earth. They're still very hot, but they're not hot enough for this carbon to fuse. For stars that are 25 times the mass of our sun, things turn out differently. They use up their hydrogen quickly in just a couple million years. They use up their helium in about 500,000 years. They squeeze down, they crunch down and fuse carbon for about 600 years, oxygen for about 6 months, silicon for about a day, and then at the end of the process, there's a massive star with a layered structure, an iron core surrounded by concentric shells of lighter elements, but the iron core doesn't produce any more fusion. As a result, there's a catastrophic collapse that takes less than a second. The star blows up in a supernova explosion. This is an example of a supernova exploding in 1994. It actually happened a long time ago, but we saw it in 1994. In this case, the star may lose 90% of its mass in the explosion, while the core is further compressed by the implosion. This is sort of how a nuclear weapon works. I'm not going to go into any more detail about that. Over the last 1,000 years, 4 supernova explosions have been observed in our galaxy. 20 or 30 probably happened, but we weren't looking or we couldn't see them. This is the Crab Nebula. It was noted to have exploded July 4th, 1054 CE. A couple other images here. If you look closely, you'll see a faint glow of something crazy going on here in the center. Shows up a little more clearly here. There's some rotation, some jetting of material this way and this way. We'll get back to that. Turning to our solar system, at the center we have the sun with a mass of about 2 times 10 to the 30th kilograms. 9 planets, more or less. This changes from 8 to 9 to 8, and I'm not sure where we are right now. Probably about 9. 198 moons with a combined mass of 7.2 times 10 to the 23rd kilograms, and a very, very large number of minor planets and meteoroids with a combined mass of 1.8 times 10 to the 21st. You don't need to memorize these masses. Just have a feel for where the material is. And then way out in the Oort cloud, we have 10 to the 11th comets with a combined mass of 10 to the 23rd kilograms. They're way off the screen here. So you want to be a star. First, you're going to have to pay your dues and form a solar nebula. Our sun formed from a collapsing interstellar gas and dust cloud. These clouds are common in the spiral arms of the Milky Way, our galaxy. You've probably seen this image before. It's known as the Pillars of Creation. And if we take a step back, zoom out from this image, or composite of images, you can see that it's a very small portion of a very much larger dust cloud. Now, if this is to be shocked by a passing shock wave from a supernova, then portions of this dust can collapse into a rotating solar nebula. The collapse of the cloud that formed the sun transformed gravity into heat, and this heat ionized the gases in the planetary ring. As the sun's magnetic field sweeps through this cloud of gas, it speeds up the revolution of the ionized gases around the sun while slowing down the sun's rotation. This is much how an electric motor works, in that the magnetic field that's generated is always moving faster than the rotor. So it's the magnetic field that's grabbing on magnetically to the rotor that ultimately turns the engine in this case ultimately turns the solar system. It's this difference in rotational speed between the magnetic field and this gas that's known in engineering terms as slip. During this period of time, the solar ring broke down into 10 concentric rings at specific radial distances. This is more or less correct. This is due to gravitational effects from our sun. Water, methane, and ammonia liquefied and wetted the solid particles, helping them stick together like 1 kilometer toxic mud balls that we call planetesimals. If you've been to Scotland, or if you haven't been to Scotland, but about haggis, for some reason, haggis always reminds me of these planetesimals, toxic mud balls. If you know what goes into haggis, you might agree. At this time, the sun was ejecting large amounts of gas and strong radiation from its early proton-proton reactions that blew all the gases that had not been trapped by planetesimals towards the outer rings. So these gases blast past the inner rocky planets to the outer planets, which are in much colder portions of the solar system. And because they're colder and obviously much further away from the sun, they're able to accumulate these gases, and therefore we get the gas giants, Jupiter, Saturn, Neptune, and Uranus. If we look at isochron of lead isotope ratios from a number of chondritic meteorites that are believed to represent planetary bodies, a destroyed planetary body in this case, we know that the meteorites are the same age because they all fall onto this same line, an isochron, same age. The age of the meteorites was determined by the slope of this line to be 4.55 billion years ago. This was discovered by a scientist named Claire Patterson about almost 70 years ago, and he was really accurate then. We haven't changed the date of the origin of the solar system very much since the 1950s. He did such a good job at determining it originally that we haven't improved upon it. I've posted a story about him and the discovery of this age as a PDF. It's worth a read. You don't have to memorize it, but it'll give you a real feel for how serendipity enters into science in a big way, and how Patterson was able to solve two major problems: the impending insanity of the world and the age of the solar system. They are related. Within a few million years, the swarm of planetesimals in each ring had stuck together into a single body, with the largest planetesimal in each ring exerting the strongest gravitational attraction. These became the planets. Formation of the planets was so rapid, perhaps in thousands to tens of thousands to millions of years, that the relatively short-lived radioactive isotopes formed during the supernova explosion were trapped in these planets before they could decay. This plastic mash of planets began to separate, with heavy metals sinking towards the core, which is going to cause the core to heat up. The hotter the material became, the faster the sinking. This is known as the iron catastrophe. Catastrophe meaning to turn over. So in this case, the planet turned over internally, separating the heavy, dense materials from the lighter materials, or less dense materials. In order of abundance, these were hydrogen, helium, methane, water, nitrogen, ammonia, and hydrogen sulfide. Planetesimals formed within the solar ring, but also far beyond the outer ring as well. Way out in the distance, they were too far from each other to hook up and form planets, so they remain as isolated bodies to this day. During the last 4.6 billion years, many of their orbits became perturbed by passing stars. Some of these became comets. They're thrown out of their safe orbit into crazy orbits that may run into other planets. A small comet hit Siberia in 1908 in Tunguska and destroyed the region. These are photos taken from 20 years later, and they showed the blast zone where the impact generated shock wave forced trees down for hundreds of square miles. The contemporary reports include descriptions of bright lights, flashes, the sound of thunder, sounds of gunshots or cannons, and pillars of fire. There are reports from as far away as England of lights in the sky. It's really kind of pushing it, but it's possible that that was visible from England. And fortunately, there may be billions more of these in the Oort cloud beyond the solar system. So billions of more opportunities are still out there. This is Tunguska, where the 1908 event took place. And this is Chelyabinsk, also in Siberia, but quite a bit further to the west. As these comets approach the sun, they're heated and excited by the solar wind, and this pushes the ionized volatile material out. And along with small grains This forms the tail of the comet. So the comet is always pointing towards the sun. No matter which direction it's traveling, it's pointed towards the sun. So if it's moving in this direction, the sun would be over here. If it's moving in this direction, the sun is still over here. It's always going to blast the tail away from the sun. Now, if we could get a sample of this material is going to represent the primordial composition of the solar system. Now, fortunately, we just did get a sample of one of these, and in 3 years, we'll know the answer. I'll post up a video of that. It's kind of an interesting story. Certain meteor showers are caused by the Earth passing through the tail of a comet. What we see depicted here are a number of images of Halley's Comet, the most famous comet. Here is the representation of Halley's Comet from 1066 CE. This is from the Bayeux Tapestry, a very important, very famous wall carpet, essentially. And here we see people pointing at this comet. Now, 1066 AD is important because that represents the Norman conquest of Great Britain, or Britain at the time. This is a depiction from later on, a painting. This is an etching of the 1682 appearance of Halley's Comet. If we go back in time a bit more, here we have a painting known as the Adoration of the Magi, representing Jesus as a baby. It was painted in 1305. Halley's Comet appeared in 1301. So it's very likely that the inspiration for the Star of Bethlehem was the passing of Halley's Comet in 1301. Now, this did appear in the Middle East just prior to the historic birth of Jesus. So it probably wasn't the East Star, the Star of Bethlehem, but it inspired future versions of that. So how long have we known about this? We've known since 366 BCE, where sighting was recorded in Greece and in China. Most likely that's Halley's Comet. In 240 BCE, again sighted and recorded in China. Now, this is roughly the same time as the Warring States period in China. If you know your Chinese history, this is an important period when China started to become organized as a regional power as opposed to a limited series of fiefdoms. In 66 CE, it foretold the destruction of Jerusalem by the Romans. In 451 CE, this is the defeat of Attila the Hun plains, another major historic event. 1066, we just mentioned this, William the Conqueror brings the Normans to Britain and orders the production of the Domesday Book. This is a book that recorded everything that was known about Britain in 1066. Kind of a cool visionary effort by Bill the Conqueror. In 1222, Genghis Khan begins his parade across the world. 1456, the Ottomans invade the Balkans and lay siege to the city of Belgrade in Serbia. And 1910, we're in the modern world, so we're no longer susceptible to weird superstitions that comets cause things like this. We'll get back to that in a second. Now you can see from this sketch here the ellipse of Halley's Comet. So it approaches the sun, gets very close to the sun inside Earth's orbit. Subsequently, it moves well out into the solar system with each passing. Now, this is a really interesting quote. It's both humorous and creepy. I came in with Halley's Comet in 1835. It's coming again next year in 1910. I expect to go out with it. It will be the greatest disappointment of my life if I don't go out with Halley's Comet. The Almighty has said, no doubt. Now here are these two unaccountable freaks. They came in together, they must go out together. Mark Twain wrote this, and he died on April 21st, 1910. And that night, Halley's Comet appeared in the sky. So again, kind of creepy, kind of cool, kind of funny, just weird. So 1910, we're in the modern world. This is 100 years ago. How did we react? We totally freaked out. There were reports from scientists, I believe initially in Europe, that the comet was going to release hydrogen cyanide gas, and that was going to kill everybody. So people began to barricade themselves into houses. They began to pray. The scientists had described the Earth passing through the tail of the comet, which did happen. Everyone was freaked out. So life is going to end. Ranchers were killing themselves in New Mexico. Fear of the comet is apparent in the city. Meanwhile, in France, comet parties are the fad of Paris. So much like hurricane and COVID parties today, there's always a group of people that just ignores what's going on. In this case, these people were right. In almost all other cases, these people are wrong.